Yeah. So basically, most of the applications will have multiple layers. Only applications like some Notepad, Notepad++, or like our Visual Studio IDE, right? So all these are standalone applications. But most of the consumer-facing applications or customer-facing applications will be having multiple levels. Okay, if we have 2 levels, this is your user interface. And this is your backend application. So basically there will be endpoints, like you'll be calling your backend API and you'll be getting response. And these backend APIs will interact with database. It will call the database for reading data and writing data. Okay. So whatever data you enter here, you submit, it will go to the backend. Backend will do, basically you'll be doing some validations, like yesterday we saw Angular validations. So that validation you'll be doing here, and everything is fine, you'll send it to backend, and backend again will do some validations here. And then if it is everything right, it will create or like save data in the database. And then it, once the save is success, it will return back success, and backend will respond to your call saying okay, success. And here you'll be showing some alert. The record is successfully saved. So this is basically multi-tier application. This is tier 1, this is tier 2, this is tier 3. Okay, so most of the applications, like 90-95% of the application will have a similar architecture, but not only 3 levels. Like it can have like tens of levels. Okay, because this backend will call again some other application, and some other application will call some other application, and again it will call the same database, and again it will go here, and it will go here, and it will come here. So this is like, the architecture is very complex in old big systems. Okay, but any simple app which has a data store and which has a UI, which has a backend, this is how the flow works. Okay, this is a multi-tier application. Now the advantage of using this multi-tier application is, let's say this is your mobile application. Okay, or like assume that it's a tab, and this is a mobile, and this is another mobile. So this is iOS, Android, and iPad. Okay, so you can use the same API to develop these user interfaces also. So the main advantage is you will be using same backend, but you'll have multiple front ends. Basically, you'll be targeting mobile users, you'll be targeting iPad users, you'll be targeting web users. So all these users, your application, your backend application will be having support for all these kind of users. And user point of view also, let's say you create your account in this web interface. Now you want to install a mobile app, then you made some orders here, and then you install the app and you log in with the same username and password. So what will happen? The same orders you created in your application will be coming here also, from web application to here, right? Because it has the same database, same API, and everything. So it adds more user experience, right? Instead of, let's say you create an account here, everything will be new, then you'll be shocked, like, oh, what happened? So this because of the single backend, you'll be having all these advantages from user point of view. Okay, so this is multi-tier application or 3-tier application in general, but there is 2-tier applications also, but these 2-tier applications are non-existent now. This is your server. This is your user interface. Okay, mostly static websites, right? Like college websites or blogs. There'll be two-tier applications. You send data, not you send a request, you get a file, and it will be rendered in the browser. So basically, static website like college websites and personal websites, personal blog website, right? So those will be the static websites. So they will not have any database here. So they just develop pure HTML and CSS website, and they send put it in the server, and they will expose on some domain. So this is called two-tier application. So this is gone now. People are not using this. So okay. For this, they were using Apache web server and Nginx server, and there are HTTP Lite. So these are like basic servers, web servers, and these will not do any dynamic functionalities. You can just say copy paste your HTML files, and then those HTML file will be sent to your browser whenever a request comes. That's it, nothing else. But because these backend applications came, when people started using Java, Python, PHP, Ruby, all these languages came, right? The .NET. So all these languages, basically, they will generate whatever HTML you are seeing on fly. Like some data, they'll get some data, and if let's say the application shows a list of 100 users, and it will get data from the database, and it will generate HTML table with 100 records in here in the backend application, and then send that HTML back to the user. Okay, so here that facility is not there. This is static website. There is no data coming from the backend. So whatever data is there, that is static data hard coded in your HTML. So here you can basically manipulate data based on the data coming from the database, or maybe some backend application, other application, because this can call another application also, right? So that data will come and it will manipulate and send it. But even this was like, in 90s, in 2000s, these people are using static website, right? Most of the time they were using this architecture, two-tier architecture, and now it is gone. Most of, like 99% of the people are using, because there is no use with the static websites, right? So now at least after 2005, people started, when Java came support for backend application, then people started developing this architecture, like generating HTML in the server and sending back to the browser. Okay, the server will send HTML itself to the browser. But now what happened, this architecture does not support multiple UIs. Okay, if you develop this application to generate HTML for browser, it will generate only that HTML and send it to it, but it will support only web interfaces, but not the mobile interfaces. Now the people are using the new architectures, that is let me clear this out. Okay. Now, what people are using is REST APIs, and they are having for single application, they are having multiple databases, and for single application, they are having multiple. Multiple modules. One more module here. Okay, module 1, module 2, module 3, and DB1, DB2, DB3. Okay, and here you will have your mobile app and your web app, your desktop app. Okay. Now, mobile app also they can have Android and iOS. Okay. Now what will happen? They expose this data using the REST endpoints, and each will call each REST endpoint, and it will get data. Okay, something like this. These calls will be happening on fly. I mean, depending on the, of course, the feature and the requirement. And these applications will basically go to the database and get data. Let's take example of student application, like the college application. Okay, so this will allow us to get student microservice, and this is a faculty microservice. This is a admin microservice, and this database will have admin related data. This database will have faculty related data. This database will have student related data, and this will expose only student related endpoints. This will expose faculty related endpoints. This will expose the admin related microservice endpoint. And now, based on the user interface and like where you are in, if you're accessing student page, okay, if you're accessing student page, it will call the student API and it will get data and display. If you're calling the faculty, if you're using the faculty screen, and it will go to faculty screen, faculty microservice, and get that data. And here also, if admin is logged in, it will basically make call to the admin module from backend. So the advantage of having this architecture is, let's say one team is working on this one, second team is working on this one, third team is working on this one. If they added some new API or maybe some fixed new bugs, right? They can only deploy this application. They can only replace this application, or I mean upgrade this application. So meanwhile, these two applications will be working. So users who are using these two modules, there is no outage. So once this is deployed, they can go back, they can go to this module and they'll replace this module, and then go to this and they'll upgrade this one. The same way, basically there is no outage for the whole application. In case of, let's say, the server went down for this one, crashed or something, the student module. So other modules will be working for other users. Only student module will be having the outage. So people can fix that and put it. But if it is a single application like this, the 3-tier architecture, right? So your entire code will be in here itself. Then let's say this is went down, then there is outage for entire application, right? So that's why people are using microservices. So each module is called microservice because it's a small service which only gives your student related information. The same way, this is a small service, it gives faculty. Same with admin. And it will have its own database. Let's say database went down for some reason. Okay, all these things will go down in production for random reasons. So let's say the database went down. When this database goes down, again only student related information will be down. Other application, other sections of our application will be working. Whenever you click on student link or something, that time only it will not work, but other parts will be working, right? So this is the main advantage with the microservices. So these are called microservices, and the data transport mechanism is called the REST services, because microservice will expose REST endpoint. REST endpoints are nothing but the endpoints you basically callable endpoints. So basically endpoints are nothing but URLs. So this will expose some URLs, and this will expose some URLs related to faculty. This will expose some URLs related to admin operations. And the data type they are exposing will be JSON. Okay. So JSON object is what we are seeing, right? Like this. name, and this is data, a comma, and another field, another field, another field. This is the data transport mechanism used in REST services. Okay, so only REST services we use this JSON structure. Okay, in REST services we will not use any other structure. Like we have XML also, but XML we will not use in the REST services. REST means JSON. That's it. REST equal to JSON, JSON equal to REST. So whenever you call the backend API, backend URL, right, it will return JSON response. So that JSON response you can get in your mobile app or web app or desktop app, and then you will show it properly somewhere in a table or something. Mm-hmm. Okay. So actually we saw this. Course outline. Yeah. Let me. I'm sharing my this one. So if you go this, yeah. So this student list is a JSON, right? The JSON object. And whenever you call a student API, it will return this data basically from the server. Okay. And this data you can format and show in the browser, the table we created, right? So this way you can create a table and you can basically represent the data in the table. Okay. So REST means JSON. JSON means REST. So there is no other way people use. Okay. Now in order to show, let me clear this out. Okay. To tell the example you're talking, right? So basically, you can basically remove that and add a different one because this is a bit complex. So I would recommend you to add another example instead of the payment related one. This is your Angular application, and this is your backend. This is your database, and when payment something initiated, it will call this, and it will call this and create a order object in order table. And once order is created successfully, it will say order is created, and then immediately it will create payment request. In payment table, it will show how much amount and how much what is the status. Status will be initiated or something. Okay, status column will be, and then it will send request to payment gateway, and payment gateway will interact with card network. It can be Visa, Master card, and we have something else also, right? So it will basically interact with the card network, and upon success or failure, it will return back the data to the payment gateway. Payment gateway return to your backend. It will say if it is success, if it is failure. And the same thing we will basically update here, the status to success. And then the same status will be sent back to your Angular application. It will save here and it will send here. So now we'll say success in green color or something. So that's how this entire flow will be initiated. So next time when user comes and sees, goes to the transactions page or some page, we can basically go to the backend, and the backend will call the payment table, and it will look for the user ID. Only it will get transactions associated with that user ID who logged in, okay, who made that payment, and it will filter with the user ID and get only those payments, and it will come back here and it will basically show all the payment success, failure. So all the list of payments you can basically show in a table. So this is how the application, like payment applications, will work. Most of the applications, the payment gateways will be PayPal or Stripe, and we have Wise Transfer, I think. So these payment gateways we use, and these guys will be giving some APIs again, like REST APIs. So you will be using that REST APIs and calling their services, and they'll be calling again the card network, and card network also will have some kind of a API. So these guys will be calling them, and they will basically do interact with your bank. Okay. Bank APIs. They'll interact with respective bank APIs based on your card, and then that bank APIs basically checks your balance, and it returns if balance is full, and if you're able, if your card is not blocked. So they'll have hundreds of checks. Once all checks are passed, then only it will return success to the card network. Card network again inform the payment gateways. So it's like, entire application. We cannot even tell how many tires involved in it. So this is just a representation, but in real time, there will be like 15-20 layers will be involved. Just a single payment to go through. Okay, but UI side will not see anything. We'll just initiate the payment and we wait for like a couple of seconds, right? So in that couple of seconds, all these things will be happen.
Okay.
So yeah, I think you can explain this architecture if they ask. But at least try to remember the structure. Like you'll be calling a backend, it will go to the payment gateway and then card network, and you will get back the response, and then you will record it in the database, so that because you record, then only it will be available in your next screens, like past payments or past orders. Otherwise, it will not be available. If you just report in the UI whether success or failure, but you did not record it in the database, it will not show for other screens. So you must save everything in your database. Database is like a persistent storage, right? So what happens like last year also you can have in the database. Okay. So any questions here? Like, did you understood the flow?
Yeah, I understood.
Okay, perfect. Yeah.
Okay.
Let me stop the recording.